Oscar, welcome to the show, man. I appreciate you coming on. We're going to be talking machine learning today. I think it's good to start from the very basics. What is machine learning?
Okay, yeah, thanks, Alan, for the invitation. Right, so machine learning is basically the methods or statistical methods for the computers to learn something from the data, right? And there are different types of machine learning, right? There is when I studied my master's degree, I mean, we didn't like to call it machine learning or data science because those were terms that were popular nowadays, right? Nowadays, what is popular is AI, right? At the end, all of it reduces to statistical methods or analytics, right? So machine learning is that. There are statistical methods, and there is prescriptive, predictive, and analytics. So we're going to see a little bit of those applications today with what we're going to show, right? So that's basically it. If you have some data, you can tell the computer how to learn from it and to better assess what you're doing.
Okay, and for today's session, you're going to be sharing an Excel add-in, which is to
That's right.
analyze
Yeah.
oil and gas datasets. So let's just jump on the screen and see what you have to share with us.
Okay, let me share the screen. So yeah, I have prepared some this Excel file just to as a walkthrough what we're going to talk about today. Um, and yeah, this is of course what we're talking about today is machine learning for geoscientists. We are not going to dive into. We know that when we talk about machine learning, usually Python comes in the conversation, right? It's the de facto programming language for doing machine learning, right? That's why pretty much a lot of people has picking up Python in the last few years, and now that's being obviously held by just using AI just by itself, right? Yeah, so people is not learning to code anymore, but they're just learning to use the cloud or whatever other LLM to do this stuff, right? But what we're going to see today is machine learning for the scientists, even though the add-in that we're going to talk about is not meant only for the scientists, right? It's for whatever people that wants to do predictive analytics or prescriptive analytics, and they have some data sets that they can use, right? So machine learning is quite ubiquitous across many domains. And today we're just going to explain a little bit how to apply this specifically for geoscientists, right? So I just want to go through some concepts, basic concepts in ML, right? So when you hear the word features in machine learning, there is like it's basically a matrix operations. You can see it in that way, right? So A is equal to Y is equal to X times Y, where X are your features or your data set. What that means for us, that could be log data, completion parameters, or reservoir attributes, right? So, or even production data, of course, even in time series data. So those were going to be basically be our features depending on what we want to predict or understand. Then we have the target, which is usually denoted by Y. If you see any machine learning books or jargon, these are usually how they put the equations, right? X and Y. Y is the target. And this is the thing that you wish you'd measure, right? So lethal facies, EOR, breakdown pressure. So any target that you want to understand, that you want to predict, even ESP lifetime, right? So to do predictive maintenance or all these kind of things, right? So you can, it depends on your problem. How do you build this data set and these targets, right? And the model is a correlation, right? It's a multidimensional correlation that is learned from data. So this is what we're going to train. The training is when we hear about training, it's about calibrating the correlation against the wells, or what do you know from where do you know the answer, right? And this is also called supervised learning, right? When we have some data that we already want to predict, we have the labels, we have everything, and we want to predict um, with this model on new data that is coming. But in machine learning, we also need to understand a test set. When we talk about a test set, usually when we train the model, we need to apply it to some blind data, right? So you can train it in your training data, but you always have to test it on some data that the model hasn't seen, right? Because that is how it's going to occur in the real world, right? So you don't have all the data. Always, you will have new data that is coming to you, and that data won't was not seen by the model, right? So we always need to define a test set for that regard. And as I was mentioning, there are some types of machine learning. In this case, there are classification, regression, and clustering, right? So these are the most common, let's say, examples or interventions that we do with machine learning, right? So we talk about classification, is because we want to predict a category, right? So if you think about, I don't know, lithofacies, right? Um, we want to predict if at a given depth, given the density log, given a neutron log, uh, given the resistivity, so you have a sand, or you have a shale, or you have a limestone, etc. Right? So that's classification, because we're going to train the data on this type of. We want to train the data to predict a category, right? Not a number. When we want to predict a number, that's when it's called regression, right? So, for example, porosity or community production, pressure, etc. Whatever you can think that it is a number, right? And clustering is when we want, for example, when we want to group wells that behave similarly, right? And you can also apply this to any other kinds of data, core data, well logs, you name it. So these are some jargon that I wanted to explain up front, and to bring some examples on how that looks like in the geoscience jargon, right? So just some very basic comments here. We know that we always have to be mindful that ML doesn't replace your physics. So we always have our models that have been developed with the underlying physics. We have Darcy's equation, we have material balance, and we have to recall that sometimes the engineers, when we want to use machine learning, we get into a problem where when we want to predict something that is already governed by some well-known physics, right? So that it's a very common problem when people want to apply to machine learning to everything they have at hand, right? They have some data and they want to apply machine learning just right away. And that's even more prevalent nowadays with LLMs, right? You can quickly throw data to an AI, an LLM, and start doing, machine learning. And some people miss a lot on the physics part and the governing equations, right? So we always have to be mindful of that, and it's always a complementary approach uh, to some well-known physics, right?
Can you come here as the user and impose some physical relationships, so physics informed machine learning is about that?
Yeah, that's right. So there are some methods like physics-informed neural networks, right? PINs. They are very common right now, where you constrain your machine learning model with some governing equations, right? So it has a weight where when the model doesn't have enough data, it tries to use the physics model. And when it has a lot of data, it tries to use more the machine learning model. So those are very good to have constraints around what the machine learning will predict, right? But But yeah, those are very, very nice. And there is a lot of papers coming out also in the last few years with pins. It's been used a lot um, in the oil and gas industry, especially for subsurface applications, right?
You have in rows 10, 11, and 12 there, classification, regression, clustering. Where would you put optimization? Is that a separate category altogether, or it's somewhere?
Ah, that's a great question. Optimization is inside each one of this, right? So when we learn about this in the academy, in, let's say in university, when we take classes out of this, there is a different subject that is called. So this what we're talking about here is machine learning or statistical learning, and there is another class in university that is called operations research, right? That's where you touch upon optimization and statistical simulation, right? Now, optimization as a whole is inside machine learning because when we train these models, we are optimizing for an objective function to to decrease the difference between the observed data and what the model predicts, right? So there is gradient descent, there is so all of these types of algorithms that optimize the model with the data that we have, bro. So optimization is part of the machine learning mechanics already
Yeah.
because it acts as the fundamental engine to decrease the difference between the real and the observed data, right? And there is the operations research approach where you use optimization, like I don't know, in simulation, for example. We want to optimize the model for. We want to optimize the wells or the water flooding schema in such a way that we maximize the EOR in 5 years, right?
Hmm.
That type of optimization doesn't require machine learning, or we're not using machine learning on it, right? In that part, we are optimizing a set of parameters as long as we get to a target, to maximizing target. And we can use evolutionary strategy, we can use simplex methods, um, convex optimization. When we talk about that type of optimization, it's usually referring to to operations research, right? So machine learning uses optimization, but optimization is a whole subject on itself, right? We don't have to use optimization. We don't have to use machine learning for optimization, but machine learning uses optimization as their inner workings, right?
Yeah, that's a very good distinction you just made. So as the user, you may be running an optimization exercise, but you're not going to be using machine learning for that. But machine learning has embedded an optimization in its way of working through all these tasks because it's
That's
a
right. Yeah,
minimization of the error function. So
and that's right. So
okay,
that's how it basically works. Yeah.
nice,
So great. So that's why usually we hear this a lot in simulation or in anything that we do in subsurface as well. Garbage in, garbage out. If your data is not good, it's not clean, it's not. We haven't done the work of cleaning the data properly and making sure that it has good quality. We're going to have a pretty bad model as well, right? So that applies for, I mean, we have heard this so many times across, in subsurface, we hear this since day one when we do simulation, for example. And also training and test split is non-negotiable, right? So just a word of caution, like anyone who tells you that their model is like 99% accurate is telling you something, right? So that is very, very, very hard to achieve. And we always need to test the model on a blind data set. Yeah, so these are just some basic concepts that I wanted to go through before we delve into the add-in.
nice.
So last year I started working in an add-in called FormulaML, and if you don't have the add-in, you can just go to your home ribbon, go to add-ins, uh, add more add-ins, and you see all of the official add-ins in the app source, right? You just look for FormulaML, and you will see it here, right? So it's published. If you have access to the add-in icon here in the store, you should be able to download it, and it will download quite quickly. So once you are in there, this add-in is what we're going to use. So why are we talking about the add-in, right? That's the first thing, right? Why do we want to talk about the add-in and in this context of machine learning? And why are we in Excel in the first place? So over the years, when I have been working with colleagues, I pick up programming since I was in university, but there is usually a lot of people that does a lot of work in Excel and don't necessarily feel with programming, right? And these people have always there are a lot of colleagues over the years that have told me that, I mean, they want to learn machine learning, they want to learn these algorithms because they are doing predictive analytics, they're trying to understand the reservoir, they're trying to understand many things, and they know that it's out there, but they always see the coding as a barrier at some point, right? That's not the case anymore with the coding agents. But even though you want to be able to assess or to see or to understand what you're doing, right? So given that there is this gap between what the people wanted to do and the stopper of what the new programming language to learn a new programming language meant, I start creating this add-in, right? So once you download the add-in, you will see this. Um, you can quickly do an account. It's free. It's during I have been running this beta testing for quite a while, and it's still going on for free. So you can sign up with your Google account. So the reason that we have to do it this way, that is not, that we have to do an account, is that uh, this runs on servers. This runs on the cloud, right? So let me just reload the add-in. So that's the reason that why you have to do an account, right? It's nothing else. This runs in the cloud, and in that way, I can make sure that real people is using the add-in, right? So once you get in there, you create your account, and will be able to log in. The first thing you see, it's this task pane. You have your details in here, and you can do a quick tour if you want, right? So I know that a lot of people hasn't seen machine learning up close, right? And this new concept of machine learning in Excel, we haven't been doing this at all, right? So that's why I included a quick tour here. So in here, um, you will see how to use this in very quickly. You will learn the basics of machine learning, what we're talking about and what we're going to go through today. And you can do this interactively, right? So you can load data set, you can do this, you can run this interactively, and then you will be able to see the data, right, that is popping up. So this will populate data automatically. You can read all of this. You can go to the next step. It will explain to you what are the usual conventions that we use in this setting, right? All of this is Excel formulas. You won't see coding or programming languages anywhere. You only see Excel formulas, new Excel formulas, of course, but nothing on the terms of programming, right? You can run this, and you can do this complete walkthrough by yourself, right? So you see, it created this spreadsheet, and now it tells you what it is, right? It tells you the details on why are we doing what we're doing, right? What the data set is, why are we using data frame objects? We're going to go through all of this, right? You can start working right away as soon as you download the add-in, right? And once you finish the tour, you can run all of this. You also have more examples here. I'm adding examples constantly, so you can run full examples of regression examples, classification examples. One in clustering is coming. There are two methods here. You can run the example right away with this button, or you can do a walkthrough which explains uh, each part of the example, right? And you can run it interactively. So you can do this, and it will start populating the example just one step at a time, right? So you can do this in one go, or you can do this and go and read the documentation as you go, right? So all of this, Isabel, I'm not going through all of these examples specifically right now because these are more generic examples in the machine learning community, right? There are some basic data sets. It's not oil and gas. What we're going to go through today is some oil and gas examples, right? But what I'm saying is that you can download the add-in and go up and running just in the first as soon as you download it, right?
Just curious, what is it that runs in the backend here in the server? What is it? Is it R? Is it Python scripts? Is it a combination of
Oh,
things?
it's a Python app that runs on Azure.
And so this philosophically is similar to Excel Wings, for example. You create a bridge and run Python in the backend.
Yeah, so there is Excel Wings, which is the Python module.
Yeah, that's the one I was referring to before.
Okay, yeah, that's the. So yeah, this is using a special version of Excel Wings, which is called Excel Wings Server.
Right.
So yeah, that's for many kind of apps. So it's not directly tied to a local environment.
Yeah,
You can make a local environment as well, but if you need, more processing capacity like you need for some machine learning workflows,
for sure.
uh, you can do that. And I can do, and that's why I was able to create this because I can use all the power of Python and even other programming languages. Even I've used some JavaScript, and so for the front end, I can even use Rust
Yeah.
and to power this, right?
Yeah, just referring to the mental model for someone who is an Excel user, there's a bridge
Yeah,
between
that's
the
right.
Excel and
That's
somewhere.
that's a good thing. They don't even need to know that this is running Python on the back
Yeah,
end, right?
exactly.
So I mean, we're talking about that in here just to go on the weeds of it. But as any Excel user, you can just download the add-in and start clicking stuff, and you go up and running and see the results, right?
Yeah,
So, but it's doing the calculations, proper calculations that we use in Python. And in fact, this add-in has a testing. I have a testing suite where I test all of the methods that we expose here against the official methods that we run on the Python community as well. So they are all in hand. So if you all happen to also know Python and you know how to run this in Python, you can double check the results that you get here and what you get on the Python code. So
yeah,
then we will match, right? So yeah, that's the add-in. Here is just a little bit of what this means. There are some system resources here. We're going to talk about what this cache usage means. Usually, with the workloads that we do in Excel, we don't need to worry about basically the storage. I mean, almost it is very hard that somebody is running a 50 megabyte Excel file, right? So that's so far. This is what we can hold in terms of cache storage. This is quick storage. It's not like you cannot run more than this, but this is just a storage for retrieval. We're going to talk about what this means when we see the functions, right?
yeah.
But usually the overall use or 90% of the cases don't need to worry about this part. Okay, so let's go with the formulas, right? This is just a task pane. This is just for you to run examples, to go up and running with the walkthrough, but this is not the main purpose of the add-in, right? If you know your way, once you've used the add-in, you will just go straight to type Excel formulas.
Yeah,
So, and this is what we're going to do here, okay? So if we start typing, right, formula, and we type ML, you can see that the IntelliSense here in Excel already puts all of data that all of the functions that FormulaML has. Right, it has a lot of functions. Um, you might be perhaps, I mean, how can I use all of these functions? That's why the examples are. But also, you can also see what this means, right? So once you put the function, you can see the arguments that are expected, and you might be thinking, okay, but what do the arguments mean? So the good thing about this is that you can go to the formulas tab and you can go insert function and you can see the documentation just right here in Excel of what this function does, right? So this one creates a logistic regression object. These are the arguments. What is C is the inverse of the regularization strength, must be a positive flow. A smaller values specify a stronger regularization, right? So this is the part where, as a user, okay, we have to skip the programming part, but we cannot skip the rigorous part of what the statistics mean, right? So if any user wants to go ahead and keep using this, right, we'll need to understand, okay, what the logistic regression does, at least, right? What does this regularization strength means for this algorithm? What is this algorithm doing, right? All of that is written in books, and we also have, of course, documentation online as well, right? So
Okay, I
we
was going to
can,
ask. So you have a link inside the
so
add-in
there is
that takes you to
always
the, yeah,
for all the formulas that you put in here, and this happens for all the even for the native Excel formulas, right? You have this link here,
yeah.
so you can click this link, and it will pop up the official the documentation page, right? And here you have the same description that you have in Excel, and also way more detail on when to use this, some examples, and some remarks, right? And some related algorithms, right? So it's like, so yeah, I mean, it's like you have documentation everywhere. The objective of this is that I'm assuming that whoever starts using this add-in or hasn't used machine learning at all, and I just want to try to make it easier for everyone to start using this and to apply it to whatever they're doing, right? So yeah, you can start right away, right? And it will you can see that while it's calculating on the server, it has this little icon here uh, that it's working on. So it returned an object, right? This is a logistic regression object. We're going to talk about what objects are. So yeah, so that's for the introduction. Right now, we're going to get into more of the details and on how this adding works, and then we will go to the specific examples. Okay, so the first concept in FormulaML is that uh, machine learning objects in programming and in Python are quite complex objects. So they are not just values; they have a hierarchy of a structure of coefficients, of matrices. A lot of stuff is going into one of these machine learning objects, right? So that's why FormulaML has this concept of object handles, and not only FormulaML. If you have used the Python in Excel functionality, you can see that when you run Python in Excel, this outputs some objects that are similar to this,
Hmm.
right? Or whoever has used this. So what I'm using here is just the same concept. So we are translating complex objects that only exist in Python to have a reference inside an Excel
Yeah.
cell, and so we can refer to them in other functions, right? The user doesn't need to know all of the details of what's going on behind here, but it will have some data to refer to, right? So for instance, in here we are going to create a database object, right? So FormulaML also comes with some data sets built in, and when we run this, you see that it's going to load the Iris data set, a classic data set for classification, right? And it tells you what it is, and it tells you what it returns. So it returns a data set object, which is a data frame containing the features and target variables. So what we talked about at the beginning, right? So features and targets. So it returns a table of data compressed in a single object. Because most of the time, this is the way that we work, right? Doesn't mean that we won't be able to see what's inside. We will be able to see what's inside, right? We can just click, we can just write, for example, sample, and we want to sample this, and we want to see the first 5 rows of this data set, and we should be able to see it, right?
Yeah.
So this is just putting the data, because this can be thousands of rows. It can even be higher than the number of rows that can fit in an Excel file, right? So Excel has a limit of rows. So this can hold data sets that are even larger than that.
Yeah.
Um, Another example is we have just seen that when we run some functions, some Formula ML functions will spill, what time is it? Will spill data. So we will go a little bit quicker here because we're running out of time. Here we're just running, I also include the force data set here. So I'm just running some functions in here to see what is available in that data set. Right? If I run this, it will return all of these wells, right? And if I run this part, it will return all the columns available in the force data set, right? So this is just an example on how some functions work, right? Some functions create objects, and some functions spill values. So with that, let's start with the oil and gas demos. Okay.
Could you integrate or bring an assistant or an agent into here to provide guidance as to how to navigate this in terms of explaining the functions, the arguments, how to extract stuff from a database using natural language?
That's
Uh,
the cherry on the cake. We'll put that for last part.
okay,
So
great.
just to give you a spoiler, we are able to use cloud with FormulaML. So you will see how to do that
Okay,
uh,
awesome.
at the end. Now let's go with the demo. So I think a lot of people in the community knows about the Force 2020 dataset, right? That was a competition of lithofacies classification and some seismic related competitions as well. I have put this data into Formula ML as well to try to tackle this oil and gas oriented audience. Right, so we are going to pick some wells and log curves. So I'm writing this by hand, or I can just refer to the list of available wells that we have on the data set, right?
Yeah,
When I run this function, right, I was able to see what wells are in the data set. So I can just copy or reference to those values. And here I'm going to put 4 wells. I'm going to use 4 log curves, including the one that I want to predict, which is the lithology, right? I will create a dataset object, which we talk about, right? The way to create that is using the Force 2020 datasets Force 2020 function, and we will select 2 wells, and we will select all of the columns and all of the columns that are available, right? So that will create a basically a 38,551 rows by 5 columns data frame. This is the shape. I'm just here, you know, printed the shape of what this data set has, right? So when I run this data set loads here in this object. If we want to see what is inside this data set, let's see the first 5 rows just to understand what it is in there.
Yeah.
We can just use the sample, right? And we can see what's inside of it, correct? Um,
Hmm.
Now, when we go ahead, now we're going to start doing some very basic machine learning operations, not data cleaning operations. So this data set has some missing data, right? There are some columns that don't have data at all. So I can just run here the function drop missing rows just as a way to quickly do this. And you can see that now the shape after dropping those rows is 38,400, right? Before it was 500. So yeah, I'm just dropping some
Hmm.
rows in there just to try to clean the data quickly. Sometimes you don't want to do this, you want to impute some data. But for the sake of simplicity in here, I'm just dropping the rows, right? You can describe your data set here with the describe function. You can have how many data do you have in each one of the columns, what's the mean value of the gamma rate on the density, right? Standard deviation and some percentiles too, right? Just a quick way to see your statistics of the data set that you have at hand, right? And now we're going to start doing some modeling. Now, first, we want to select the features, right? We want to select the data set that we're going to use. So we don't want we for X, remember that we don't choose the target, right? We just need the columns that we're going to use to predict our target, which is going to be the leaf faces. So we in here in this function, we're going to say select the columns of this data framing here, which you already dropped the missing rows, right? You already have some clean data here. And then you're going to select only these columns from this data set. Okay. So that's the first thing. And for the target, we're going to do something similar. We're going to select the data set, the data frame that you already cleaned up, and we're going to select the data that you want to predict. So we have created our X and Y, our features and target data set separately, right? Now we're going to split it. Remember that the splitting between training and test was not optional, right? So we're going to do that. We're going to choose a test size, which is going to be 25% of the data is going to be test. We're going to choose a seed. This is just to for the to for because this splitting that we're going to do here has some randomness in it. In order to create the same splitting every time, we're going to define a seed. And if you want to do a different splitting, a different random splitting, you just change the seed in here to another number, right?
Is
Or
that
you can
test
just
size, sorry, mate, that test size is at 25%. Is that what that means?
uh, that's what I mean. It's a fraction, yeah.
And
So it's
is
point
is
25.
is that the order of magnitude you usually use for that? 25% of the
We
set?
we
Okay.
can use between 10 and 30. You can see more often perhaps 20%.
Yeah, okay,
You
so got
define
it
the
right.
test time, yeah.
And the other question is there a reason why you picked only 2 wells instead of the 4 in your data frame?
Uh, Just for simplicity and that we can see the results quickly. You
Ah, okay,
can
it's just for
select
speed now
all
with
of
the
the
demo.
wells.
Yeah, okay.
Yeah, yeah. This is just to quickly see the demo. And in fact, we're going to see how this changes once we choose 3 wells, right? So that's
Okay.
we want to see that incremental effect as well.
Yeah.
Now let's separate the data, right? So we select our our X, right? In here we use the train and split. You can see what this means here, right? What each argument it is. We're going to here we define the test size, right? This is the 25% of the test size. We define the random state, and the data set type it's 0 because as you can see here in the documentation, the split returns, if you want to return the training set, you have to put 0 here. And if you want to return the test set, you have to put 1. So in here, we want to define the training set, and we define 0 here. So that's what we're doing, right? So We do the same thing for the test set. In set that we use one, and we do the same for the target train and the target test. We select the same,
Okay.
but we don't select this one, and then we are good to go. So we are going to start doing some modeling, and here we're going to use two models, right? We're going to use a logistic regression model because we want to do facies classification, which is a category. We want to select a classification model. And whenever you hear logistic regression, even though it says regression, the fact that it has logistic in there, it means that it is the classification algorithm. So it's a classification algorithm that classifies. It has an activation function that picks either 0 or 1. So internally, what this does, if you have multiple categories, is that you run this several times, and then you classify between different categories. So whenever you see logistic regression, it's a classification algorithm. In fact, the way that we have it classified here in FormulaML, you can see that you can assess the logistic regression in the classification namespace, right? So first, we create the model. When we first create the model, it is an untrained model. We're just defining the object that is going to be trained later on, right? So you click on this, you press in here, enter, and then you will have logistic regression object. Now, that object isn't trained. That object doesn't know the data yet because we haven't passed anything to it. In here, we can just define the penalties. We can define the intercept and another, computing related things, but we haven't passed the data yet, right? So you just hold this. You just hold this in here. Now, if we want to fit the model, that's when we use ml.fit, right? We pass the model that we want to train, we pass the X data set, and we pass the target, the Y, right? Once you run this, you have a trained model, which, as you can see, has a little brain on it, right? That means it's trained. And you can test the accuracy of the model. You can use eval, a score, and you can evaluate how accurate it is, the model, and you can select the model, the X, and the Y, the original Y. So that way you can evaluate how accurate it is, right? You're passing the original data to see how well it did on your data set. And you see that it's 69. So in here, the closer to 1, the better in terms of accuracy, right?
Something akin to the a correlation coefficient.
Yeah, I mean, this is not R square in this case.
Sure, but
Uh, yeah, but it's
can be
similar.
thought in
It
those
is the
terms. Yeah,
it is the amount of labels that the model got right
yeah,
versus right. So it got right almost like 69% of them, right?
yeah.
So for comparing, we're going to use a random forest here. We're going to use a scalar about. So we are going to talk about this perhaps later. We're going to use random forest classifier. Um, in here in FormulaML, we can build pipelines. So this is more of a bit of a more advanced concept in machine learning or in how to do and practical ML. There are pipelines. So sometimes you need to do a specific steps on your data before you can train your model on your data. Okay. This is what the pipeline is for. So instead of giving the algorithm directly to the data, you can define a pipeline that is going to use first a scalar, which is going to scale the data. If you have data with different magnitudes, it's going to scale the data so the features are going to be comparable between themselves. This is not relevant to random forest. I'm not sure why I put this in here. This is more relevant to logistic regression, actually. But this is crucial for algorithms that are distance-based, like k-means clustering, like linear You can also use this for linear regression. You can use this for key nearest neighbors. So all of the algorithms or even support vector machines, all of these algorithms are sensitive to the magnitude of the features that are between each other. So you need to standardize the data set before you can apply machine learning on it, or before you can train a model. And this is just one example. You can do different types of pre-processing steps on your data, right? So that's what the pipeline is for. So if you want to say, okay, I want to do these steps in order before training my data, you can use a pipeline. So I want to use first a standard scalar, and then I can fit my random forest classifier, which is random forest is a tree ensemble classifier, which is one of the best and the most complex. It always scores higher on the benchmarks. If you don't know what algorithm you use, you usually just go straight to go on random forest, right? Unless you want to understand the data and you do some linear regression related things, right? In this way, I have defined my pipeline, and now I can train my pipeline on my data in the same way that we did it with logistic regression. I can pass my data and I can pass the target, right? And now if I test the accuracy of this pipeline that has random forest, you can see that it's much higher than the one that we have for logistic regression, right? So yeah, this is a side-by-side comparison, 40% better. And now let's try to do some blind well uh, plot, right? So you can predict what you will have on your I'm going to choose this blind well. You see this well is 915. We haven't used this one in the training. Remember that we used the
Yeah,
first two.
yeah,
So we're going to select the third one to predict. These are going to be the features I'm going to train, are going to predict, sorry. And I create the data set that I'm going to test, right? So I'm going to take the data from this well. I'm going to do the exact same process as before, drop the missing rows out of this, and I will start building the data set to predict what will be the late facies in here, right? So here is how I use predict, right? So here there is ML predict.
yeah,
I choose the model that I want to use for prediction, which is this pipeline that is trained already, right? In this case, and I want to pass the data set. In this case, it's going to be the new X from the blind well, right? That we just load, and we will have we can calculate the accuracy of this blind well, right? So you can see that the accuracy here, even with the random forest in this well, is 67%. Right? So that's why this is going to be always higher than what you have on the test, because this is on data that it saw, that it was able to see, and this is data that it never saw, right? So yeah, let's try now to see how this looks like, right? So here is the predicted. I just created the Excel chart here just to show how this looks like, right? So you can see that, and these are the lithofacious code, right? So you see that the shape is not very well here. It is missing a lot of labels that should be perhaps higher, right? In here, it kind of tries to predict for the sandstone. But what I want you to see here is that what happens when we increase or when we change our model, right? Right now, what we have done is to build basically like like what we do with any Excel formula, right? You change a value and it's going to change everywhere that it touch, right? So let's do that. When we run the random forest, there is an argument that is called a number of estimators, which is 5. But what if I increase this to, I don't know, let's say 20? So perhaps I should have copied the. the image, so we are able to compare. But yeah, so now it finished the training. It got this. So right now it's calculating the prediction down here. And you can see there are some differences, right? Unfortunately, yeah, I will need to copy this, but what I mean is that the same way that you have always assembled your Excel files, whatever workflow that you do, you're able to do it with
Mhm.
with Formula ML, right? It's just as any Excel formula. You change a value, and everything that is linked to that cell is going to change,
Yeah,
right? Now, if you want to use, for instance, let's say, hey, Oscar, why you didn't use more data? I mean, yeah, you're right. I mean, why I didn't do that? So let's select the other well, and it's going to run all of what we built so far, right? It's going to take even more time because it's going to even run the logistic regression thing. It's going to rerun the random forest. It's going to rerun everything, right? So let's see how that looks like. Uh, so yeah, you finish calculating the data set. You finish getting the new features. It's finishing getting the training data, test data.
the way you outlined the different steps here in these sheets is also the sequence in which this thing runs in the back end. So it goes step one first, then step two, or everything runs simultaneously.
Yeah, that's a good question. It runs asynchronously. So what that means is that if one function here depends on the other function, it is going to see that it's calculating and it will keep trying until it has the result.
Yeah,
Uh, Once it has the result, it will start calculating again. So that's how it goes. So now I changed, right? I put more an additional well in there, and you see that in here we weren't able to get these values right before,
yeah.
and now we're able to do so,
So that's
right?
97% accuracy now.
So well, yeah, you jump a lot. Yeah, I think they are very similar, perhaps. Oh, I made a mistake here. Sorry. You know what I did, right? So I made a
They trained
mistake
the well.
because I trained the well on which I'm testing, so that's not fair. So I need to change this to well 17, and then we can see the
That's a little
the,
bit
the
too high.
okay. So yeah, 68%. Okay, we'll try to go faster with the other demos because we explain
Yeah,
a
so this
lot
is
of what
for
we're doing.
classification. Yeah, no, that's good, man. Yeah, it gives a general overview of the process. No, that's fantastic.
Let's quickly go over this one. You can also do regression. So I also put some data sets here. There is like I don't know if I've shown this before, but I have also a web page which is called petrodb.cortez.com, where I am collecting all of the open data sets in Parquet files. The reason I'm doing this is because I love DocDB, and it feels like magic that when you have Parquet files hosted online, you can give DocDB a query to only fetch the part of the file that you want to get.
Mm,
To me, that's amazing. So I'm putting that all of these files, which are gigabytes of data normally, right? And I'm using it inside FormulaML because in FormulaML I have also put a function that it's called. Let me see. Bring the data. Well, I'm not be able to show here, but there is a function that is called query, which is is running DocDB on the backend. So if you have Parquet files somewhere, you can also query them with FormulaML. Okay, so yeah, in here I think the objective is to predict the cumulative oil of these wells. This is how the data looks like. Right, I have the data here. So I want to predict petroleum and with a lot of this with all of this data, right? So here I'm doing the exact same process as we did before, except that this is regression. I'm logging data, I'm combining the features, I'm I'm connecting, oh, here's the SQL, the query. So if you are comfortable with SQL, you can also use SQL here, right? You can select the columns here. You can filter by subtypo reservoir is not null. You can do all of that as well. So this is the main difference of this demo compared to the other ones, that you can use query as well to query some more complicated data sets.
Yeah.
And if you're comfortable with SQL, right? Um, I'm doing the exact same thing here. I here introduce some additional, some more complex objects, transformers, column transformer, which just transforms numerically some columns on the data set. And here I'm training a random forest regressor, right? So if you see the pipeline here, the pipeline is a bit more complicated because it's using this data transformer, and this data transformer is using this. If somebody has fiddled around with scikit-learn in Python, they know that this is a complex, let's say, workflow, which you are able to do here as well, right? So yeah, you get an R square. This one is R square, right?
Yeah.
0.74 because we're talking about regression. And what happens if you have new data and you want to calculate what is going to be the the oil cumulative that you will expect from this well, right? So you define your data the same way with the same shape that you have your input data, but now you have the new values, right? You convert this data to a data frame first. We provide a function that is called convert to data frame because most of the FormulaML functions use data frames to do the machine learning related calculations, right? You have the predictions here with predict, and you have the predicted value here, right? So it's 51,000 of cubic meters. And here you can see a plot of the predicted versus real value of the model, right? So here we saw regression, very similar process as we did before. And finally, clustering, right? Clustering is unsupervised learning. You don't provide labels here to the machine learning object. So you want to provide the features and tell the machine learning algorithm to say, okay, um, if I want 4 clusters of this data across the many dimensions that they have, how would you group them, right? I want to understand that. So here I'm using the same data set, the wells. I am using a standard scholar because when we are using clustering with k-means, it's important to scale. So we're using a standardization process. And I might also doing some principal component analysis. This is just for reducing to be able to see the data, right? The reason I'm doing principal component analysis here is because I want to plot the data in 2D. So I want to extract the 15 dimensions that this data set had. I want to extract into these main components to plot it in 2D, right? So that's what I did here with PCA. We also have PCA here. And I'm plotting these clusters with the colors, right? So it predicted 4. I asked him to give me 4 clusters, and this is the way that it classified it, right? So, but now, well, what happens if you and as sorry, and as I mentioned before, if you run this, yeah, if you rerun this, it's going to change all the clusters. It's going to be a typical Excel calculation.
Yeah.
But now, but what if you want to further analyze this and keep using it in Excel? So you can put these labels, these clusters back into your data, right? So you can see here that this is data that I use to analyze the clustering, right? So in here I will use, okay, now give me the labels for each of these wells,
Mm.
right? I want to know the labels that these wells belong to, right? I train my machine learning algorithm. Now I want to try to understand my data, right? And you can just do what you can do in Excel as always, right? You can do a pivot table. So you use 4 clusters, right? And let's see what is the average of of oil and water across this well, right? So this is water, cumulative water, and cumulative oil. And if you change, of course, from clusters, you can see that why it makes this comparison, right? So it first has a group of wells with a lot of liquid. This is a group of wells with a lot of water, and this is a group of wells that produce a lot of water and a lot of oil. And these are groups of wells that produces more oil than water, right? So this is how you tie back normal Excel calculations, normal Excel features, right? You know, who doesn't use the pivot tables to understand the data, right? So this is how you combine machine learning uh,
Yeah.
in Excel while keep using Excel, right? So, um, and finally, let me see, yeah. Finally, you asked me for if we can use FormulaML with AI, right? So I think pretty much everyone has seen Cloud,
Yeah.
right? Cloud doesn't know anything about FormulaML. So, but if you go to the FormulaML webpage, which is formulaml.com, um, oh, see, I need to change this, but let me see. Okay, wait. I don't have it here, but I'll post it on the when we go online. Yeah, this one. This is still I haven't pushed the updated version of the landing page, but yeah. Um, Formula ML has a skill for cloud. Um,
All right.
so you can download the skill, and it's going to download a zip file,
Yeah.
and you can now go to cloud, and
Co-work.
you can use where do you I think you define here in this.
And
So if I can recall what this is, but if
and
you go here
customize.
in customize, yeah, but if you go here and you want to say manage skills, yeah, it will pop up this,
Yeah.
and you can add the Formula ML skill with this upload skill. You drag the zip file here,
Yeah.
and then you'll have in your account the Formula ML skill. So for that, let's just wrap up with that, and let me show you what let me see Excel, the surrogate model. So yeah, in here to show that, let me maximize the screen. I have some data set from some simulations of a synthetic data. And these simulations have some targets that I want to predict, right? They have some objective functions. I'm doing assisted history matching, right? And I just have the data set. That's it. And I have some features, fault transmissibilities, seal fraction, sand fraction, four volume multipliers, and these are the results of the simulations, right?
Yeah.
And I want to use Formula ML to build a surrogate model, right? A model that can predict these values here, the objective functions that I need. So if you have loaded the skill correctly, it will show up in here. You can see that it's Formula ML, right? And you can tell it um, build a surrogate model from this data where the targets are the columns that start with OF. Okay, and you press enter, and then well, you know what happens next. So you will start thinking how to use um, the skill. Hopefully, I still have some. Yeah, I still have some tokens left. So yeah, I starts recognizing data, identify the target columns that I want to predict, and it starts asking me questions, right? So you have 6 target columns. Yeah, I want to predict only OF1 for this one. Which regression model do you want to use? I want to use random forest. So let's see what it does, and it creates a new sheet here, and I think we'll start populating the values, right? Some problems here. Yeah.
So the skill provided to Claude provides all the context for Claude to start writing the formulas onto the Excel
Mm,
sheet as per the question, as per the prompt.
yeah, that's right. So I didn't give it any additional context of how to use what formula ML is or anything. I just reference the skill, you see,
Yeah,
and it will have everything. So what the skill has inside is some common ways to use formula ML,
yeah,
right? So let's see, because this is not spelling correctly. Some common composition examples. So it basically builds everything. It knows what each algorithm does. It knows when to use which. It knows that this is using Python on the back end, but the user doesn't need to know that.
yeah.
And definitely, Cloud doesn't mention this when it outputs the results, but it knows that, so it can uh, build the workflow in the right way, and using standard ML skills,
So,
right?
so the skill is a bunch of workflows and a specific bunch of cases, and skill all it does is it uses intelligence to determine the workflow needed and writes the formulas in the right sequence.
In the right sequence, then it knows what an object handle is. It
Yeah,
knows what each function outputs. So you see, it's doing all of that, right?
yeah.
And at the end, you can ask it also to plot the result. You see, it's doing some predictions here. So it's building all of that. So if anybody doesn't still, because I know it takes, everybody's getting used so much to using LLMs, uh, you can now use also LLMs in Formula ML. But difference is that you already know how formulas work.
The big takeaway here for me is this is a fantastic tool for somebody who wants to delve into machine learning without having to go to an external coding platform and stay within Excel. So you've created the bridge, the magic happens behind the scenes, and on top of it all, there's a documentation with the explanation of everything that goes behind the scenes with the formulas, the arguments, etc. And on top of it all, you have the ability to bring Claude in as an assistant to help you through these workflows. So I think it's just a matter of letting yourself play with this. And again, I mean, this is a fantastic playground for anyone keen to delve into machine learning within Excel. Fantastic, man.
Yeah, let's see. Yeah, well, keep me posted, and everybody who sees this, yeah, just feel free to test the tool. Drop me a line. There is an email there in the Formula ML webpage, so you can reach out to me then. And yeah, looking forward to see how do you find the tool.
Fantastic, man. Great work. Thank you very much for coming on. Have a good
Yeah,
day.
thanks a lot, Alan.
Have a good day, man. Cheers.
You too. Bye. Take care.